Hello, welcome to my channel Chemistry Classes. Today we are going to discuss methods of purification of organic compounds. Once an organic compound is extracted from natural source or synthesized in the laboratory, after an organic compound is either isolated from a natural source or synthesized in laboratory, the next crucial step is its purification. Impurities can significantly affect the compound's properties and reactivity, making purification inaccurate for their application. The choice of purification of method depends primarily on the nature of the organic compound and the type of impurities present. The primary techniques employed for purifying organic compounds include sublimation, crystallization, distillation, differential extraction, and chromatography. Right? The ultimate confirmation for compound's purity is often determined by its sharp melting point or boiling point. Pure compounds exhibit distinct narrow range for these physical properties, unlike impure substance, which show broader range elevations in their points. First one is sublimation. Sublimation is a unique purification technique based on the principle that certain solid substance can transition directly from solid state to gaseous state and vice versa. Right? So, without passing through liquid, they easily converted solid substance into gaseous without converting into liquid phase. This phenomena occurs upon heating. What happened? How this solid is converted into gaseous phase with the help of heat. Right? So this method is particularly effective for separating sublimable organic compounds from non-sublimable impurities. For example, if you have a mixture of naphthalene, right? You have a mixture of a naphthalene and common salt, NaCl. Naphthalene is sublimable and sodium chloride is non-sublimable. Heating the mixture gently will cause the naphthalene to sublime. The naphthalene vapors can then be cooled and collected as a pure solid, leaving the salt behind. This is sublimation. Similarly, we can take another example of camphor. Camphor can be purified from sand using sublimation. As you can see in this picture, this is the process of sublimation. What happened? We can take one example. Camphor can be purified from sand using sublimation. Place a mixture of camphor and salt in this china dish, and cover it with inverted. As you can see, we have to cover this with inverted funnel. Stems with the cotton plug. We have to cover this with cotton plug. Gently heat the setup using a Bunsen burner. As the camphor heated, it sublimes and its vapors rise inside the funnel. Upon cooling, the vapors solidify and deposit as the crystals on the inner wall of the funnel, while the sand remains undisturbed in dish. When we heat the mixture of sand and camphor unheated, sublime and its vapor placed inside the funnel and sand left behind in a dish. This is sublimation. In short, sublimation is a purification technique based on the principle that certain solid substance can transition directly from solid into gaseous state and vice versa without passing through liquid phase, and this phase occurs with the help of heat. We have two examples which we have discussed, that is of camphor and naphthalene balls. Next, purification method is crystallization. Crystallization is one of the most widely used and effective techniques for purifying solid organic compound. It relies on the difference in the solubilities of the desired compound and the impurities in a carefully selected solvent. We will discuss their process. Their process is the impure solid or impure compound is dissolved in minimum amount of suitable solvent. As you can see in this picture, the first picture shows that the impure solid is dissolved in a solvent, suitable solvent according to the compound. The key here is to choose a solvent in which the compound is soluble at room temperature but highly soluble at higher temperature. Impurities should either be very soluble or very insoluble. Very soluble means and remain in the solution, or insoluble means removed by hot filtration in the chosen solvent. In next process, what happens? The solution is, as you can see in the second picture, the solution is heated and concentrated to obtain a nearly saturated solution. This means evaporating some of the solvent, right? Upon slow cooling, the pure compound crystallizes out of the solution as the temperature drop. As the temperature drop, the solubility of the pure compound decreases, leading to its precipitation in a crystalline form. Due to their different solubility profile, impurity either tend to remain dissolved in the solution known as a mother liquor or completely insoluble, so that they can be filtered out from the solution. The crystal of the pure compound are then separated from the mother liquor, and then washing and dyeing processes happen. In this, the collected crystals are usually then washed with a small amount of cold pure solvent to remove any impurities, mother liquor and then dried. As you can see in this third picture, the hot solution is allowed to cool so that the solid appear as a pure crystal, and in the fourth one, the cold solution is poured off to obtain the crystal, and the crystals may be dried by passing through them the sheets of filter paper. Sometimes a mixture of two solvents can be used for the crystallization. Sometimes we can use some mixture. In this, what happens if the compound is highly soluble in one and very sparingly soluble in other? For example, we can take to purify benzoic acid, right? So it can dissolve in hot water. We have benzoic acid and we have to purify it or dissolved in water. Upon cooling, pure benzoic acid crystals will form white impurities, and if more soluble, will remain in the water. If the solution is colored due to impurities, activated charcoal can be added during the hot dissolution step to observe that these colored impurities. Repeated crystallization may be necessary if the impurities have solubilities comparable to that of the desired product. Next is distillation. Distillation is an indispensable method for separating fluids or liquids, or for separating volatile liquids from non-volatile impurity. This technique is used when we get difference in boiling point, when we have difference in boiling point of the components in a mixture. When a liquid mixture is heated, the component with the lower boiling point vaporize first. These vapors are then cooled and condensed back into liquid form, which is collected separately. There are several types of distillation, and it's suited for specific separation challenges like simple distillation, fractional distillation, and steam distillation. We'll discuss all three one by one. First is a simple distillation. This method is used to separate volatile liquid. This method is used to separate volatile liquids from impurities, from non-volatile impurities. Liquids with a significant difference in their boiling points can be separated using simple distillation. For example, a mixture of ethanol and water can be partially separated by simple distillation. The ethanol, having a lower boiling point, will vaporize more readily and can be collected. In a simple, or we can in typical simple distillation setup is like this, as you can see in this picture. The liquid mixture is heated in a round bottom flask, and the vapors, as you can see, this is a round bottom flask and the solution is heated in this flask, and the vapors formed rise and pass into the condenser. This is condenser. The vapors are passes into this condenser. Where they are cooled by circulating water and revert to liquid, and this pure liquid is then collected into receiver flask. This is what? This is a receiver flask. This is, in simple words, what happened. The compound is placed in this round bottom flask and they are heated. Their vapors with the help of condenser went into the receiver flask. This is simple distillation. Fractional distillation. When the difference in boiling point between two liquid is small. Why we use this fractional distillation over simple distillation? Because when we have two liquids, right, and their boiling point between two liquid is small, less than 25 degrees Celsius, simple distillation is inefficient because both liquids will vaporize and condense simultaneously to form extent. Fractional distillation is employed in that cases. The key, the very important component in fractional distillation is a fractionating column. The fractionating column, as you can see in this picture, I have taken all this picture from the internet because for better understanding of this topic. This is a fractionating column. This is the importance of fractional distillation. This column, which is fitted between the distillation flask and the condenser, as you can see, this is condenser and this is distillating flask, and this is placed between these two. This column is designed to provide a large surface area for repeated vaporization and condensation cycles. As the vapors ascend the column, they undergo series of partial condensation and re-vaporization. With each successive cycle, the vapor becomes progressively richer in the more volatile component. By the time the vapor reaches the top of fractionating column, they are almost pure in the low boiling component. The condensed liquid is then collected. The liquid remaining in the distillation flask become enriched in the higher boiling point component. Fractionating columns are designed in various forms, such as those packed with the glass beads or rings. They are made of different types like glass beads or ring and have internal trays or plate. All have similar aim at maximizing the surface area for efficient heat exchange. A notable industrial application for fractional distillation is the separation of different fractions from crude petroleum such as gasoline, kerosene and diesel. This is all about frictional distillation. Steam distillation. Steam distillation is a specialized technique used to separate substances that are steam volatile. In this, steam volatile substances are used and immiscible with water. In this method, what happens? Steam from an external steam generator is passed through the heated flask containing the organic compound to be distilled. The organic liquid and water form an immiscible mixture. When steam passes through, both the organic liquid and water vaporize. The total vapor pressure, we can say P total above the mixture is the sum of partial vapor pressure of the organic liquid and the partial pressure of water. As you can write this, organic plus water. The mixture boils when vapor pressure or total vapor pressure equals the atmospheric pressure. Since pressure organic is less than the atmospheric pressure, the organic liquid vaporizes at a temperature lower than its normal boiling point. The mixture of steam and the organic compounds vapor is then condensed and collected. Since the organic compound is immiscible with water, it forms a separate layer in the receiver which then be easily separated using a separating funnel. As you can see in this picture, the mixture of steam and the organic compound vapor is then condensed and collected. Since the organic compound is immiscible with water, it forms a separate layer in the receiver which can then be easily separated using a separating funnel. This technique is commonly used to purify aniline from an aniline water mixture or help in extraction of essential oils from the plants.